I'm going to be showing you how to solve problems involving projectile motion. A motion with a motion that has two dimension. Let's read the problem. An object is launched at a velocity of 40 ms in a direction making an angle of 50 degrees upward with the horizontal. We have here three questions. The first one is, what is the maximum height reached by the object? Second is, what is the object's total flight time between the launch and the ground? Third is, what is the object's horizontal range? I am showing you how to solve the first one, which is the maximum height. We have to analyze the problem. We have to identify what are the given data. And we have their VI. It represents as the initial velocity, which is 40 ms, theta, 50 degrees angle, and 9.8 meter per second square with meter per second square, which is the acceleration in this is constant. It's not given in the problem, but knowing the fact that it is a projectile motion, which is the gravity is involved, then you have to use 9.8 meter per second square. It depends on the problem if you it depends on the problem if you should use the reverse sign, which is a negative sign, negative 9.8. Now for the maximum height, we have here the formula as hm equals vi sine theta squared over 2a, substituting the value of the data to the formula. We have 40 ms sine 50 squared, closing open parenthesis square. So you have to execute first the operation inside the parenthesis before doing the square, and you have to divide this 2 multiplied from 9.8 ms. Here I am using the Desmos calculator that you can just Google. It's a free software, online software, for calculating problems, especially those problems with trigonometric part, or you have to use trigonometric functions. Later I can show you how to use the Desmos calculator using your either web browser or your phone. I'm actually using this video for dev. It's just I cropped the video so I can use it here. This is a video lesson for my deaf students. Now I squared the answer as 47.90 meters. That's the maximum height. Proceeding to number 2, we have to find the object's total time of flight. The given here is still the same from the problem. I just want to rewrite the given so you would know where I get the data. For the students to find this problem easier, since the projectile motion is very complicated, it's a big part of physics, and many find it hard to solving problems to this type of motion. So I already compartmentalize all these formula that they can use so that they will just look this compartment and determine what formula they can use for the problem. Now I have here 2tm equals to vi sine theta, close and open parenthesis, over acceleration, substituting the given data there. before multiplying those values inside the parentheses, you have to execute the operation inside in this parenthesis first, which is a 40 sine 50, and then multiplied it to 2. But using the Desmos calculator, you can just encode the formula or the equation straight ahead. However, because I already tried it, some of the equations, there are equations that you cannot encode, like encode all of them once, but you have to separate some operations to another operation so you can get the correct answer. That's what from my it's based from my experience, of course. Okay, for the horizontal range, I am now using this formula. The range here is represented by r, and the range here also means distance or displacement. From where the object was thrown up to where it was at a certain time. Same data again from our problem. Now for the formula, range equals initial velocity squared sine 2 theta. The theta here is the angle over acceleration. Encoding this data to Desmos calculator. Okay. 40 ms squared sine theta 50 over 9.8 meter per second square. The square of 40 is 1,600. Now, like this equation, I did not write all the data at once, but I had to execute it one by one. Now, multiplying 1,600 to 0.984, and dividing it to 9.8 meter per second square. So the answer is 160.78 meters. Writing all the answers to the questions. For number 2, we've got there 6.25 seconds. That's the total time of flight. And for maximum height, it's 47.9.